was muted. Wonderful. So we highlighted the unit circle. We drew a triangle. We picked a random point. Hypotenuse is 1. This side is x, and this side is y. So Katoa, based on this triangle, if I call this angle theta, what's sine of theta? Opposite over hypotenuse. In this case, it will be y over 1, which is just y. Okay? 2, if I do cos of theta, adjacent over hypotenuse, which would be x over 1, which is just x. And if I did tan of theta, it would be opposite over adjacent, which would be y over x. Oh my. This changes everything. Why? Well, if we wanted to think about the unit circle, and we wanted to think about points on the unit circle, instead of writing them as x comma y, what's x equal to? Cos of theta. What's y equal to? Sine of theta. So that means any point on the circle, instead of thinking of it as x and y, I can now think of it as cos of theta and sine of theta, which is a huge, big idea. Because now we can do some mental math we never, maybe couldn't do before.
What do you call tan?
Okay, we'll get to tan in a second. Okay, but this cos theta comma sine theta, we're going to summarize this later. This is the first big idea. This is a big idea because you can do something like, you can tell me, let's do this point right here. What are the coordinates of that point on the unit circle? What's the x coordinate? What's the y coordinate? The radius is 1. Negative 1, 0. Because you went 1 in this direction, right? And you haven't gone up or down at all. So because the coordinates of that point are negative 1 and 0, okay, what angle would it be in standard position to get there? 180. Take out your calculator. What is cos of 180 degrees? What is sine of 180 degrees? Negative 1 and 0. That's this idea. Because we can take any random triangle and we can say the x coordinate is always going to be cos and the y coordinate is always going to be sine of the angle. If I use 180 degrees, I can just look at this and say I know that cos of 180 degrees is negative 1. I know that sine of 180 degrees is 0. If I take this point down here, which is at 0, negative 1. I now know, mental math easy, that cos of 270 degrees is 0. And cos and sine of 270 degrees, sine is always your y coordinate on the unit circle, is negative 1. That's going to be big idea number 1. That any point on the unit circle, and we'll summarize these and write these on the next page as well. Any point on the unit circle can be represented by angles and cos of the angle and sine of the angle in standard position. The equation of a circle, and that's in the box here, is x squared plus y squared equals 1. That's because if you use Pythagorean theorem, a squared plus b squared equals c squared, no matter where you draw a triangle on this, the x coordinate squared plus the y coordinate squared always has to equal 1 because of how the triangle fits. And all the values that do this, all the points that do this, make all the points that if you graph them would make a perfect circle. If that's the equation of the circle, what do we know about the x coordinate on the circle? From big idea number 1, the x coordinate is cos. So I can rewrite this formula as, I'll use theta, cos of theta squared plus, what's y? Sine of theta squared equals 1. On your formula sheet, I don't know how sine won out, but sine is always first. And also I'm going to introduce you a notation. Mathematicians are inherently lazy. They don't like writing more than they have to. So you learn all this shorthand symbols like XER. That's because they don't want to write out the sentence x belongs to the real numbers. That would take too long. Mathematicians don't like brackets because they take long to write. Not that long, like 30 milliseconds here. But they wanted to make this shorter. So how do I write this without the brackets? Because if I take away the brackets, I might think just the theta is squared and not the whole thing. So mathematicians have decided to write it this way. Instead of writing sine theta all squared, they put the squared between the sine and the theta. That means sine theta times sine theta, or sine theta in brackets squared. And instead of writing same thing with cos, they put the squared in between. So if the squared is after, it means only the angle is squared. If the square is in the middle, it means the whole thing is squared. And it's equal to 1. Yes?
Do you just have to put sine first in the first one? Or in the second one? Or do you always have to do it first?
Adding things doesn't matter, the order. Right? So 3 plus 4 is the same as 4 plus 3. On your formula sheet, sine is listed first, and cos is listed second. Sine squared plus cos squared equals 1 is what people say all the time, but it's the same as cos squared plus sine squared equals 1. Okay? And now, I'm going to get you to do some mental math without your calculator. Okay? Okay? In your head, we're going to take, what's a lucky number? We'll use 13. Okay? In your head, do sine of 13 degrees and keep 5 decimal places. Okay? Good? I want you to take that number with 5 decimal places and square it. Again, just keep 5 decimal places. Take that number, put it off to the side, remember it for later. Now, I want you to take cos of 13 degrees and remember it to 7 decimal places. Okay, now you got those 7 decimal places in your head, square it. Okay? Put that number off to the side. Take those 2 numbers that you had and add them together. What do you get? 1! You get 1. Because what did I do? I just picked a random angle. I picked 13 degrees. I got you to square it here. I got you to square it here. And it doesn't matter, this is the beauty of this formula, it doesn't matter what angle it is. When you add them together, you get 1. Unfortunately, I saw in your eyes that you actually didn't know the 7 decimal places. But it doesn't matter, because no matter what angle you have, if if sine squared plus cos squared will equal 1. You could try it on your calculator. It'll always equal 1.
That's kind of cool.
Right? It is very cool. I could offer $1 million prize if you find an angle where sine squared plus cos squared doesn't equal 1. And you could spend all night trying every single angle you could, and they'll all work. What's that? Yeah, you could do 15.3 degrees and it will work. Any angle will work. It has to be, because it's a theta in both, it has to be the same angle in both. If the angle's different, it won't work. This is going to be big idea number 2. So on the bottom of our next page, why don't we start summarizing them? Big ideas we'll write. If you turn to the next page, 470, there's some space at the bottom.
How many decimal places?
Big idea number 1. Points on the unit circle can be labeled as cos theta, comma sine theta. And that was based on that triangle that we drew that said any x coordinate is cos theta, any y coordinate is sine theta. Big idea number 2 is that sine squared theta plus cos squared theta is equal to 1. And that's just based on Pythagoras, that a squared plus b squared equals c squared. On our unit circle, x, y, and 1, that x squared plus y squared equals 1 squared. And someone said, well, where does tan come into place? If we go back to our picture here, tan is y over x, right? And y stands for sine of theta, and x stands for cos of theta. So big idea number 3 is tan of theta is always sine of theta divided by cos of theta. Let's go to our calculator just to verify that. So if I would pick our lucky 13 degrees, tan of 13 is equal to 0.463. And then if I try sine of 13 degrees divided by cos of 13 degrees, it's exactly the same. And this works for any angle. Tan of 100 degrees is the same as sine of 100 degrees divided by cos of 100 degrees. But the angle has to be the same for all of them. You can't have one angle on the top and a different angle on the bottom. So these become our 3 big ideas for the unit. And a lot of math happens as a result of this. In fact, we can do a lot of math now without our calculator that we normally had to use our calculator. Well, let me check to make sure my calculator is in degrees. My calculator is not in degrees. So I will change it to degrees. So you know how you can change things by your mode button? And in grade 12, we are going to switch a lot of times between degrees and radians. Then to get out of the screen, you go second quit. So in degrees, tan of 13 degrees is 0.230, and sine of 13 degrees divided by cos of 13 degrees is also 0.230.
Why does it change the number of degrees?
Because it would be the same thing as like, how tall are you? 5'4". She is 5.4 centimeters tall. Why do the numbers have to change if I change the unit? Well, it means something different. 5'4" is a height with feet and inches, and 5.4 centimeters is like centimeters and millimeters, and then you would be really short, right? The unit of measurement. So radian is just another way of measuring an angle, but we don't know what it is yet. We learn about that tomorrow. Also on page 570, this highlights the same things that we saw so far, that we've already talked about, that cos of theta is your x-coordinate, sine is your y-coordinate, and tan is y over x. But we also get introduced to 3 new trig ratios. You knew about sine, cos, and tan. You now are going to learn about secant, cosecant, and cotangent. And they are the reciprocal trig functions. So off to the side, it says the reciprocal of cos is secant. So off to the side, we're going to define secant theta is equal to 1 over cos theta. And since cosecant is the reciprocal of sine, we're going to define cosecant theta as 1 over sine theta. And since cotangent is the reciprocal of tangent, we are going to define cotangent theta as 1 over tangent. We are also going to notice that with reciprocals, if you flip x and y, when you flip a fraction, so we knew that tan was y over x, tan of theta was y over x. If cotangent is the reciprocal, then it's x over y. So connected to our big idea, cotangent is cos divided by sine. The key thing that you need to know as a definition, okay, this one's easy. Cotangent goes with tangent. They sound the same. The other ones are going to be harder. You have to remember that secant goes with cosine, and cosecant goes with sine. It would sure be nice if the letters matched up, that the S1 went with S and the C1 went with C, but it doesn't work that way. They're the opposites. So we're going to be doing math with all 6 of our trig ratios from now on, instead of just the 3 that we've learned up till now.